Hello guys and welcome to the second lecture. Today we'll be talking about the project scope. So basically we work for Amrish Robot and we were supplied a project scope by NF-Click Robots. So NF-Click Robots is located in Port Elizabeth in South Africa and they want to manufacture Station 01. And the station will be basically installing of a new bonnet for the Z-Lift variant 1.6i Sportline. This is an automotive company which manufactures cars. So basically what the project scope is a statement which details the project objectives, the deliverables and the requirements. So basically it's the key deliverables in the customer's requirements. So as we can see, this is a document which is 8 pages and this was supplied by NF-Click Robots to us, Amrish Robots. This first page details who prepared the document, who's responsible in terms of project leader and where NF-Click Robots is located, and also the phone number that we can contact should we need any assistance. Also details the job number, the project description, and when this document was submitted. The second page just details the table of content. So in the table of content, we find the functional requirement general, the general information, documents provided with this demand specification, and the aftercare of the system. So the third page of this document goes through the functional requirements general. So I'm just going to read through the highlighted areas which are of most importance. I will be sharing this document with you guys so you can read it in more depth if you need to. So basically what we need to do is we need to create a new station, which is Station 1. And basically the station will be responsible for the Z-Lift installing the bonnet. And this new installation must integrate with other existing control cabinets within the facility. So it should integrate with Station 05. The location where the enclosure will be installed is normally 38 degrees Celsius. So this is important. Should you do heat calculations, you should consider that value. And this is important if you need to fit in air conditions or fans. Area where enclosures must be installed is also detailed here. This is important when you choose which type of enclosure you want to use and the size of the enclosure in terms of width, depth, and height. It is also detailed here that all cables to and from the enclosures must come from the bottom or exit from the bottom. So basically we shouldn't have any cables coming from the left side of the panels or the right side of the panels or from the top of the panel. It also details the preparation. So basically Station 1 will be fed 400 volts VAC from the power enclosure at Station 5. Station 5 has various power enclosures and they are all hashtagged. And that hashtag 4 is a panel that will supply our new station, Station 1, with power. It's in the same building. So because it's in the same building, we do not require to use surge protections. Station 5, hashtag 4, that's the fourth enclosure in Station 5, can deliver 320 amps to 800 amps through a Siemens MCCB. The grounding system used in this facility is a TNS grounding system. They have also detailed the distance between Station 5, Enclosure 4, and the Station 01, which is 200 meters. So this is important when we're doing our cable calculations. They have also detailed here that the power cable that they will bring to our panel, so basically the power cable that will be coming from Station 5, hashtag 4th panel, to our new station, Station 01, will be a steel-wired armored cable. They've also detailed the electrical engineering work that needs to be done. So basically, the power distribution to the control enclosure and the robot enclosures must come from the new panel enclosure which will be installed in Station 01. Control distribution, this means for your sensors, your actuators, must come from the new control enclosure that will be installed in Station 01. The robot enclosure, in this station there will be 2 robots. So the robot enclosures must be installed next to the power enclosure and the control enclosure. Just to mention, the robot enclosures must receive power as well, 400 volts, from the power enclosure. So on page 3 and 4, they also mention here that the drawings must include reports such as the cover page, the table of content, revision page, project structure, terminal diagram, cables overview, summarized material list. And as you go further into page 4, they also explain the process requirements. So how the process must flow with regards to equipment. Station 01 must be equipped with an RFID scanner. The scanner must be from SICK or Siemens. Station 01 cell must be equipped with 6 safety floor scanners. This is to detect a person or object within the cell. The station must also be equipped with 6 safety light curtains that needs to be installed at the entrance and the exit of the new station cell. Because safety light curtains are installed at the exit and entrance of the station, muting of light curtains must be adhered to. So basically, as the car goes through the light curtain, it must not trigger an event to say somebody is entering the station, but it should be able to detect that the car is actually entering the station and it's not a person who's entering that station. 2 HMIs will be required, one on the control enclosure and the other HMI next to the station cell entrance gate. So the station cell 01 will have an entrance gate which can be used during maintenance to access the cell. The HMI next to station 01 entrance gate must be a mobile HMI with an integrated e-stop, reset and acknowledge functionalities. A key switch is preferred. Station 1 must be equipped with safety e-stops at the entrance and exit and also on the control enclosure door. E-stops must only be reset using a key. Therefore, you cannot reset the e-stops by just turning them. You need to insert a key. Station 01 also has 4 ventilation fans which must be controlled using Siemens soft starters. It is recommended to select motors with mechanical brake levers. It is also recommended to use Siemens the 3RN2 thermistor motor protection relays with motors that have thermistors. If a motor is controlled by a VFD, then the VFD must have a PTC module equipped on the VFD. There is also another 4 motors which will be controlled using a VFD, and these motors are the motors that help the skid into the cell, the motor that pushes out the skid from the cell, the motor that pushes the skid onto the lift, and the lift that takes the skid onto the buffer line. The next page, page 5, details that station 01 will receive Profinet communication and 24 volts from station 5 via a Siemens PN coupler and must be installed in the PLC enclosure. So as we can see from this, we need to design a power enclosure. We also need to design a controls enclosure and now a PLC enclosure. It also details here that the first choice must be spring-loaded terminals, which is the Phoenix PT series. They also go on to say that MCCBs and contactors must be installed as feeders and not separately. So basically they must be joined together. Control enclosure must be equipped with a Siemens Sematic ET200MP modular I/O system. So basically this will be responsible for collecting all the signals from the field and passing signals to the field. Due to unstable supply of power within this section of the city, voltage and current lines monitoring relays must be installed. Furthermore, they say the control enclosure must be equipped with an Eaton UPS for 230 volt VAC backup. Electronic circuit breakers from Phoenix are preferred for the 24 volt system. Station 01 will be equipped with 2 KUKA robots. The first KUKA robot will be responsible for picking up the bonnet from the damaged area and bring it to the location of the car body welding. The second robot will be responsible for welding the bonnet onto the front body of the car. You must note that the control of the damages is not part of the scope. Because there is welding works done by the KUKA robot, this is the second robot, the factory's fire department needs to receive a Profinet signal OK via the Siemens managed switch, which will be installed in the PLC enclosure. The last part of page 5 details that Station 01 is next to an EX Zone 2 area. Therefore, a RITO EX remote enclosure must be designed and installed within the Zone 2 area. The RITO EX remote enclosure must be equipped with the Siemens ET200 ISP intrinsically safe I/O modular system. It details as well that Amrish Robots is only responsible for collecting signals from some of the devices within the EX zone, therefore only design the remote panel. Amrish Robot is not responsible for selecting or giving power to these field devices within the EX zone. So on page 6, they also detail that the enclosure labels must have a QR code. So when you scan the QR code, you should be able to view the E-plan drawings electronically. The last part of page 6 details the calculations which are required by NF-Click robots from Amrish Robots. And these calculations include your short circuit, volt drop, and cable calculations, your selectivity calculation, enclosure heat calculation, enclosure weight calculation, and lastly, your 24-volt VDC calculations. On page 7, the scope details the documentations which are required. So the documentations which are required are your network configuration. This is your layout. So basically this details which device is connected to which. Your ground schematic, your circuit diagram, equipment cable list with length, enclosure room layout, drawings, critical spares, manuals for critical items. And the last part of the scope just details the aftercare of the system. Basically, this includes the standby, the maintenance, and the warranty of the system. And also on this page, they just give further details in terms of the signals which will be controlled by the remote panel which will be located in the EX zone. I hope there's enough information on the scope, and I'll also be sharing documents which include the NF-Click robots preferred electrical material. Basically, this includes the terminals, which terminals do they prefer, which circuit breakers do they prefer, which EX barriers do they prefer, which instrumentation do they prefer, sensors, pneumatic actuators, variable speed drives, soft starters, motors they prefer. And also NF-Click robots has shared the equipment list. So the equipment list contains the motors that will be used. It also includes the controller for the KUKA robot that will be used, which is the KRC4. It also includes that we should have 2 maintenance blocks, which are 32 amps. It also includes all the voltages, the rated nominal power, the full load current, the efficiency, the power factors of these equipment. And it also includes the manufacturers of these equipment. And you can also see the article numbers of these equipment, which is the part numbers of these equipment. The second page of this document also includes the links to the websites where you can find more information about the different motors that are being used. For example, if you're looking for information on the 1.1 kilowatt, you can just click on that link and it will take you straight to the website. So with that being said, I feel like we are ready to tackle this project. We are ready to tackle in this course the power panel, then move on to course part 2 to tackle the control panel, then later on move to course part 3 to tackle the PLC panel and that EX remote panel that's required. Thanks very much. See you in the next lecture.